So the good news is all that algebra we did and all that calculus on this example, we don't actually have to do all that work. What we can do, if you look at the notes, we got to this point where we figured out that the height was 355 over pi r squared. We took that expression, plugged it into the surface area formula, got the surface area to equal this. This is the function that we want to minimize. Now, instead of taking the derivative of that and finding the zero, we can use our graphing calculator to graph this function and then use the local max, local min feature of the calculator to figure out where this thing has a minimum. So what I'm going to do is bust up the TI-84, enter this expression into the calculator. I'm using X instead of R because that's how the calculator works. And I'm just going to graph this and then use that second calc minimum feature to find the minimum. Now, finding a good window is kind of a pain, so I'll show you really quickly. Like if I just put this in and graph it on standard, I can't really see what's going on there. A couple things, I do know that the radius is never going to be less than 0. So I'm going to change my window to go from maybe 0 to maybe just like 5. And I'll start with a zoom fit myself to see what's going on. And this graph's really hard to see what's happening. So I'm going to mess with the window until it looks good to me. If I look at this window, this y min and y max is gigantically crazy. So let's actually make a y minimum of 0. And a y max of 250, just to see what happens next. Now you'll notice that the graph's still not showing me anything here, so let me press trace and kind of see we have y values that up in the 300s, so let me adjust my window again. Maybe have the y minimum be at least 300 and go up to 750. I'm just guessing. I'll graph it again. Okay, so now here's something I could actually look at and use. Oh, that's too far. Mr. Depsic. Let's go down to 250. Graph that. Okay, so we can see the function comes down and then starts to kind of go back up. Maybe I'll pull my x values out a little bit more just to see what happens with those. But the point is, now I have a function of a graph of this function. I can see there's a minimum value over here somewhere. I'll use the second calc minimum feature to find it. So I'll go somewhere to the left of that. Click. I'll go somewhere to the right. Keep going. Click. I'll throw my guess in there. And find that the radius should be a value of approximately 3.837. All without doing calculus. R is about 3.837. And I'm hoping that if I were to take the answer from class, that cube root of 7 times over 4 pi, that it's equal to that. Well, let's just see. In class, I had said it would be the cube root of 710. Come on. Whoopsie doodle. Divided by quantity 4 pi. So please be about 3.837. So there you go. But instead of doing all the calculus, we could just graph this function and use the calculator's minimum feature to find the minimum. A lot easier.